Hello, assalamu alaikum, and welcome back, everyone. In today's session, we're going to learn in detail about how you measure different objects inside the laboratory and beyond in physics. So what is measurement? Measurement, as I mentioned earlier, is all about putting a number on a quantity. So if, for example, we're talking about length, and you have, for example, I don't know, like you have, I don't know, this is your arm, right? And you are comparing your arm with your friend's arm. And I don't know, your arm is actually, it has a lot of muscle. Forgive my horrible drawing. And your friend's arm does not have the same amount of muscle. Now, how do you compare, right? At some point, you're going to say, hey, my arm muscles are larger than your arm muscles because look, you can literally measure them, Perhaps this is like 2 and this is like, I don't know, 1.2. Haha, my arm is stronger than yours. So in order to do this, you need to have measurements. So in physics, we, have standard ways of doing these measurements. So for example, we measure length and we measure those, for example, using rulers. And then, for example, sometimes you want to measure how long something takes. If you are, bachpan mein, I used to literally count every single second when I used to go with Ammi to Pindi to, get new clothes made because it was absolute torture for me. तो उसमें क्या होता था कि I would count literally every single second. So sometimes you want to measure time and you can measure that in seconds, minutes, hours, and for that you have different kinds of devices. Then, for example, you want to measure space. You know how much space does something occupy. So for example, you have a glass. Inside a glass, how much pani can you fill it before it overflows? For that, you need to understand what something called volume is. And you need to be able to give it a unit and then measure it. So for example, centimeter cube, liters, gallons, so on and so forth. Units really matter in physics, and physics is all about measuring different quantities and then seeing what happens to them. Now, in real life, it's not really easy to measure different things because you often don't get, ready-made, very, very easy shapes to measure, especially in length. So, for example, ये आपको तस्वीर में नजर आ रहा है कि आपके पास एक तार है और ये जो तार है, it is not, straight. It is curvy, which is really annoying because it's not really easy to measure. So, if you just did this, if you're like, oh, look, I can see what it says here. Oh, it says 0 centimeters, and look over here, it says 18 point maybe 2 centimeters. So the length of this wire is 18.2 centimeters. You would be wrong because if you actually straighten this wire up, obviously what's going to happen is this wire's actual length might come somewhere over here. So in physics, we're going to study many different clever ways to measure the length of objects that you can't simply put a ruler against to study. Or usi tarike se, for example, let's take an example other than length. So for example, you are trying to measure, you're for example, running, right? You're running from point A to point B. And you yourself have a stopwatch. तो आप stopwatch को click करते हैं और फिर आप भागते हैं, फिर आप रुकते हैं, फिर आपको याद आता है कि मुझे अब stopwatch को रोकना है. तो इसमें अक्सर मसले हो जाते हैं. Sometimes you run out of breath, sometimes you forget, sometimes you just can't time it. The exact time you stop, at that time you click the stopwatch. There's going to be some error introduced. So because in physics we need to be really precise, we need to have really good measurements. For that, we've developed a lot of techniques in order to minimize errors when we take measurements. There are two kinds of errors, broadly speaking, within physics. The first is called systematic errors, and the second is called random or usually human errors, as we discussed earlier. So let's first figure out what random errors are. Random errors are those errors which, as the name implies, occur randomly. There is no pattern you can see. So they could happen, for example, because you just with your hand end up clicking the stopwatch too fast or too slow. And sometimes it's too fast, sometimes it's too slow. There's no way to predict what your next error is going to be. It is entirely spontaneous. तो एक तो ये किस्म का होता है. दूसरा किस्म का error होता है which is called systematic error. उसमें क्या होता है कि you can predict what the error is going to be. So for example, अगर मेरे पास एक weighing scale है और मुझे पता है कि उस पे पहले से एक पत्थर पड़ा हुआ है. So, if I'm going to stand on that weighing scale without realizing that there is a stone already on the weighing scale, my weight isn't going to come out right. And the reason is because that stone is going to add its mass to mine. So what's going to happen if I start, measuring different objects using that weighing scale? Every single object is going to have a larger mass than they actually do. This is a systematic error. It is a predictable error. It systematically causes the same kind of error to happen within every reading. And we'll get into these into more detail as we go along. Another concept that is important to understand that is not directly tested in your syllabus, but is nevertheless important to understand and is very helpful overall for making sense of measurement, is the idea of precision versus accuracy. This does come in the A-level syllabus, not in the O-level syllabus by these terms, but these are very important concepts to understand and they will help you with your ATP as well. So, what does accuracy mean? Accuracy means how close you are to the actual value. So, for example, I weigh 100 kg. If that is the case, and my weighing scale is telling me that I weigh 120 kg, then that weighing scale is not accurate. So, one way to help make sense of accuracy versus precision is you use this analogy of the dartboard. You have a dartboard and on that you are throwing darts. So have a look at something that is high accuracy and high precision. That would be what you see over here, which is, every dart player's dream कि मैंने जो darts फेंकी है, those are all hitting the bullseye more or less. So we say this has high accuracy and high precision. Now, the complete opposite would be something that is a really, really horrible story in which you are unable to hit what you want to hit and you're unable to hit it consistently. In other words, see this one. All the darts are scattered and none of them are near the bullseye. Now have a look at this one. This one has high accuracy and low precision. High accuracy means that all of these darts are more or less near the bullseye. But this is not very precise. Why is it not very precise? Because each individual dart is not hitting on the same place or even close to the same place. They are, there's a lot of spacing between them. There's inconsistency on where you are hitting. And what about this one? Over here, you are not accurate at all. The reason is because you are nowhere near the center, which is where you want to hit. But you are more precise. Why are you precise? Because all the darts are more or less close to each other. So now suppose you're taking a set of readings in physics. For example, you're trying to measure your weight. And your weight comes to something like this. 120.1 kg, then 110.2 kg, then like 111.3 kg, then like 125.6 kg. And my actual weight is maybe, suppose 115. My actual weight is this. So how close am I to my actual weight through these readings that I took? Not really. So we would say that this is not accurate. And is this precise? No, these readings are not even close to each other. They're not even in strong agreement with each other. So we would say this is not precise either. Now, what would precise but inaccurate readings look like? Those could be like this. Maybe I got like 120.1 kg. Then maybe I got like 119.9 kg. Then maybe I got like 121.2 kg. These three readings are pretty relatively close to each other, but they're nowhere near the actual value. The actual value was 115 kg. How could this be possible? This could be possible if I was standing on a weighing scale, but there was already a stone on the weighing scale as well. So what would happen is I would not measure my actual weight because the weighing scale would also add on the weight of the stone to it. So we say this is not accurate, but it is more or less precise. All right. And then what would accurate but not precise look like? That could be something like this. Maybe it could be you have say like 117 kg, then like 114 kg, then maybe like you have 116 14.5 kg, then you have like maybe, I don't know, 116 kg. So there is disagreement between the readings. They're not very closely in agreement with each other. There is an error of at least 1 or 2 kg, but these are more accurate than the readings before that were more or less around 120. So, and what would a high accurate, high precision set of readings look like? What your common sense says, it would look like this: 115.1 kg, 115.2 kg, 114.9 kg. These are fairly precise, respectable readings, and at the same time, they're very accurate. So again, precision means how much in agreement your readings are with each other, how close are your readings to each other, and accuracy means how close are you to the actual value.